That's it for today, class. Hope you learned a lot about energy and kinematics. Peace.
Thanks, Prof.
Wait, Professor Roman.
Yes.
I read ahead because, well, I was bored, and I read about the transformation of energy between gravitational potential energy and kinetic energy. And I was wondering, they talked about skis. I want to buy myself a pair of skis. The physics concept with skis and downhill skiing is amazing. Where can I get a pair?
Well, let me show you. Roll it.
Alright, good morning, and hello viewers. I want you to take a look at this perfectly crafted ski. Look how beautiful it is. I'm alongside my fellow companions, Miss Jillian Carter and Professor Noah Rotman. Give me a clap, boys, give me a clap. Alright, stay tuned, ladies and gentlemen, for the next 6 minutes, 30 seconds, and 45 milliseconds of fun.
There are many physics concepts that are put into place when building the perfect ski. In order to get the maximum speed possible when going down the hill, and to sustain nice, crisp turns, we turn to physics.
Yes, that's right, Noah. Downhill skiing is a complicated thing that involves the use of many physics concepts. First off, the shape of the ski is important. As you can see, it's wide at the top, gets narrower in the middle, and then gets wide again. This is so, when you turn it on edge, you put all your body's pressure on the middle of the ski, and that will cause it to bend, like this, making the turn easy.
Oh man, get a load of that! But don't think it's over quite yet. No, there is more. There is more! The reason why you can get up to such high speeds going down the hill on a ski like this is due to the transformation of energy. What transformations of energy, you may ask? Well, and Noah, please indulge us.
I will do just that. Well, at the beginning, you start with a certain amount of gravitational potential energy, which is directly correlated to your height. As you go down the hill, obviously your height decreases, and this energy has to go somewhere, so it goes into your speed.
Do you want to get up to top speeds and fly down the hill like never before?
Yeah?
Get this ski! You may be asking yourself, well, can I purchase this? Yes, you can. Anyone can buy this incredible pair of Dinosaur skis. Big kids, little kids, boy, girl, mother, father. We have skis in all different sizes, all different shapes, you name it. We have the skis that fit anybody.
Dinosaur! Now, remember, skiing is done so during the winter time when the hills are packed high with snow. Downhill skiing gives society enjoyment and thrill. It is an amazing activity to hit the slopes with friends or family. Not only this, but downhill skiing has become a fun sport featured around the world, including the Olympics. It is a great physical activity, exhausting many muscles as you glide down the hill, providing a good workout. Don't miss out on this phenomenal, breathtaking, leisurely activity. It's fun, but also provides a physical workout. Buy this ski!
Hey, all you earth-loving people, I have some great news for you. Skiing has very little impact on the environment, because, all you leave behind is tracks.
Side effects on the environment may include the grading of the ski slopes, which involves removing trees and the gallons of energy wasted in snow blowing and running the lifts up and down the hill.
So, let's get into the details of the careers related to skiing. I know what you're thinking. Can I make a ski a career? Yes, you can. In terms of manufacturing the equipment for skis, a lot goes into it. There are those who need to make the skis. This career is referred to as boutique ski maker, which involves carving and creating the ski. There are also industries that are used to produce the ski boots and ski helmets that are necessary to having a fun, safe, and successful ride down the hill.
Incredible!
The incredible jobs don't even end there. Many people are still needed to teach new skiers how to ski. And one of the most exciting jobs, though, in the ski industry is being a heli ski guide. That's skiing out of a helicopter. Don't wait now. Grab your chance to get one of these amazing jobs.
So, for those of you who haven't skied before, have no fear. Help is here. Don't be afraid of skiing.
And guess what? Skis don't stop here. They are improving every single day. There are many people out there who are advancing the technology to be safer and faster. In the future, there is no doubt the evolution of skis will continue. This being making them thinner, lighter, and they will still maintain their incredible features that allow for tight turns and easy rides. Recently, we're working on putting a hole in the tip of the ski.
Yes, this is because it makes the tip have less torsion, meaning there is less twisting of the skis as a force is applied. This reduces the swing weight. In turn, the skis are not as grabby or hooky when you're making a turn, and end up being more maneuverable and quicker. As you can see, the physics of downhill skiing is being improved constantly, improving the efficiency of skiing. It is outstanding.
So don't wait now. Call in and order your own set of dinosaur skis so that you, yes you, can go downhill skiing tomorrow. Just 5 easy payments of $99.99. Call 1-800-SKI-LIFE today. That's 1-800-754-5433.
But wait, if you call now, we'll double our offer, sending you 2 pairs of skis of your choice.
Not only that, we'll include 2 helmets and 2 pairs of goggles, and a downhill suit. Wait, no, 2 downhill suits. All for 5 payments of $99.99. So call 1-800-754-5433. Thank you for watching.
Yes! So great!
Wow, that is all some interesting stuff. But hey, on our test, are we going to have a question that has to involve, transformations of energy?
Yes, but you can actually solve these with kinematics as well. Let me show you.
Okay.
Okay, so let's see this problem. There's a skier on a hill 100 meters high, inclined at 35 degrees. The mass of the skier is 65 kilograms. What is the final velocity when they are at the bottom of the hill? So, from the question we see our givens are height equals 100 meters, our mass 65 grams, and our initial velocity is 0. But we need to solve for VF, so VF equals question mark. Gravity, as we know, is 9.8 meters per second squared, which is a constant. So, we know that at the top, the gravitational potential is mgh, and at the bottom, that's going to be mv squared. Or half mv squared, sorry. Now, VF is equal to root 2gh. So we sub in our numbers, and we get a final velocity of 44.27 meters per second. But because of significant digits, we must round to 44 meters per second. Here, we use the factor label method to convert from meters per second to kilometers per hour, just to give you some sort of an idea of how fast that really is. So, we start by doing 3,600 seconds in an hour. The seconds here, they cancel. And then we have 1,000 meters in a kilometer. Again, our meters cancel. And we're left with kilometers per hour. So we see 159 kilometers per hour. And again, we must round to 2 significant digits, which is 160 kilometers per hour. So now we'll use kinematics to solve. We should get the same answer, but sometimes you don't. Our incline, again, 35 degrees, height 100 meters. So solving for displacement, just use your trig ratios, which you should all know. So we see here, sine of 35 degrees is equal to 100 over the hypotenuse, which is our displacement. So again, sine 35 equals 100 over delta d. Displacement equals 100 divided by sine 35, just a little rearrangement here. And displacement is equal to 174.3 meters. Now we will solve for acceleration due to gravity. Again, you use some trig, and you see because this angle here is 90 minus theta, and this is a 90 degree angle, we see 90 minus 90, which was minus theta. But when you carry that in, you get 90 minus 90 plus theta. So these cancel, and your angle is just equal to theta. So you get theta here. Now, sine theta is equal to our acceleration in the x component over our gravity, which was our hypotenuse. So sine theta equals ax over g. G sine 35 equals ax. Now our acceleration is 5.62 meters per second squared. So with all these numbers, we can use these to solve for final velocity. So again, vi 0, acceleration 5.62, and delta d 174.3. So we use the equation vf squared equals vi squared plus 2a delta d. Sub in our numbers, vf equals 0 squared, which is 0, plus 2 times 5.62 meters per second squared times 174.3 meters. Now we square root all of those, and we get the square root of 1959.132 meters squared per second squared. The units are square rooted, so you get meters per second. This is how we know we've solved correctly. We get 44.27 meters per second, which was exactly the same as our last answer. So again, factor label method, just the same thing, 160 kilometers per hour. And that's how you solve it. See, the thing is, 160 kilometers per hour is clearly not accurate. The problem is, if you want to account for drag, friction, and a bunch of other things, it's pretty difficult and it's kind of above your level. So we just leave it like this.